Air conditioning system and pressurization system. The source of air to pressurize and air condition an aircraft varies mainly with engine type. Reciprocating aircraft have pressurization sources different from those of turbine-powered aircraft. Note that the compression of air raises its temperature. A means for keeping cabin air cool is built into most pressurization systems. It may be in the form of a heat exchanger, using cold ambient air to modify the temperature of the air from the pressurization source. However, a full air cycle air conditioning system with expansion turbine is typically used on commercial transport aircraft. It provides the advantage of cabin temperature control on the ground and at low altitudes. Bleed air. The main principle of operation of a turbine engine involves the compression of large amounts of air to be mixed with fuel and burned. Air bled from the compressor section of the engine is relatively free of contaminants. As such, compressor air is a great source of air for cabin pressurization and air conditioning. However, the volume of air for engine power production is reduced by bleeding air off of the compressor, and even though the amount of bleed air to the overall amount of air compressed for combustion is relatively small, it should still be minimized. Modern, large cabin turbofan engine aircraft contain recirculation fans to reuse up to 50% of the air in the cabin. This reduces bleed air volume and helps maintain high engine output. There are different ways hot, high-pressure bleed air can be exploited for cabin pressurization and air conditioning. Smaller turbine aircraft or sections of a large aircraft may make use of a jet pump flow multiplier. With this device, bleed air is tapped off of the turbine engine's compressor section. It is ejected into a Venturi jet pump mounted in air ducting that has one end open to the ambient air and the other end directed into the compartment to be pressurized. Due to the low pressure established in the Venturi by the bleed airflow, air is drawn in from outside the aircraft. It mixes with the bleed air and is delivered to the pressure vessel to pressurize it. An advantage of this type of pressurization is the lack of moving parts. Disadvantages are that only a relatively small volume of space can be pressurized in this manner, and there is no means for cooling the ambient air. Another method of pressurizing an aircraft using turbine engine compressor bleed air is to have the bleed air drive a separate compressor that has an ambient air intake. A turbine turned by bleed air rotates a compressor impeller mounted on the same shaft. Outside air is drawn in and compressed. It is mixed with the bleed air outflow from the turbine and is sent to the pressure vessel. Turboprop aircraft often use this device, known as a turbo compressor. The most common method of pressurizing and air conditioning turbine-powered aircraft is with an air cycle air conditioning and pressurization system. Bleed air is used, and through an elaborate system that includes heat exchangers, a compressor, and an expansion turbine, cabin air temperature and pressure are controlled. APU. The source of air for air conditioning does not always have to be bleed air from the compressor section of the main engines. The aircraft's auxiliary power unit, or APU, is designed to deliver pressurized bleed air for engine starting and for operation of the aircraft's air conditioning packages. Sufficient pneumatic air from the APU is routed through ducting to the packs so that the cabin can be cooled while the aircraft is on the ground with the engine not running. This is one common method for keeping the cabin at a comfortable temperature while passengers are boarding. Ground cart. When an aircraft is on the ground, operating the engines or the APU to provide air for air conditioning is expensive. It increases the time in service of these expensive components and expedites costly mandatory overhauls that are performed at specified time intervals. A ground cart is available to provide the pressurized source of air for the air conditioning packs. The cart is towed to the aircraft's location on the ramp and is connected into the aircraft's pneumatic system ducting with a 4-inch diameter hose. The connection point is upstream of the air conditioning packs. Cart air is regulated to the normal pneumatic system pressure and can also be used for pneumatic system troubleshooting without the expense of running the APU or main engines. An even better and more economical solution for cooling the aircraft while it is stationary on the ground exists. Most high-performance, medium-size and larger turbine-powered aircraft are fitted with a receptacle in the air distribution system. The air distribution system basically consists of a series of ducts that carry conditioned air from the packs to wherever it is needed on the aircraft. A ground source of conditioned air can be connected directly into the distribution system receptacle. Cool air from a ground-based air conditioner is blown directly into the cabin through the aircraft's distribution system ducting. This makes operating the aircraft's air conditioning packs unnecessary. The ground-based air conditioning unit can be a large air conditioner mounted on a truck, or it can be a fixed type such as those used in homes and businesses.